this is Geometry, Lesson 3-2, Translations. It's another form of transformation. In this lesson, you will describe the properties of a figure before and after translation. Okay, you will also write a rule for a translation. You could find an image of a figure after a composition of rigid motions. And also, you'll be able to prove that a translation is a composition of two reflections. This lesson, you have some review vocabularies you'll see and one new vocabulary. You need to remember what the image, pre-image, and translations were. Also, in this lesson, you will learn what composition of rigid motions is. Okay, let's look at explore and reason. Draw a copy of ABCD on a grid. Using another color, draw a copy of ABCD on the grid in a different location with the same orientation and label it QRST. Okay, this paper, I have copied ABCD over here. Okay, I'm gonna copy another ABCD over here. Okay, I have to look at the distances between points. Between A and B, they are 10 units away horizontally. And between points B and C, from B to C, you go up 1, 2, 3, 4, 5, and then you go left 1 unit. So we're going to talk about slopes from each point, and we're going to count slopes in order to copy these points out. So if I copy point D over here, okay, I'm gonna count the point D to C. You go right 1, 2, 3, 4, 5 units and go down 1 unit. So you're gonna put points 5 units right and 1 unit down total. Okay, and from point C to B, I'm gonna go down 1, 2, 3, 4, 5 units down and 1 unit to the right from point C to B. And from point B to point C, I'm gonna count 10 units directly horizontal from point B to point C. Okay. Okay. And they are all A prime, B prime, C prime, and D prime. The points are all primes because they represent the image of the pre-image. Okay, we're going to connect the points to finish our copy of this shape. Okay, now do you see the image and the pre-image? Yes, they should have the same points at the same position with the same side length because we counted the distance. So is this a rigid motion? Yes, because it preserves length and it preserves the angles, right? So what kind of rigid motion is this? That's what we're going to think about. Let's go back to our textbook. Okay. On another sheet of paper, you're going to write instructions to describe how to move ABCD to the location Q or ST. So after you graph the image and pre-images, you're going to write instructions. Write down all the steps that we just did. What did we do? I can say, how about I count each point from A to A prime. I went up 1, 2, 3 units up. And then, oh, this is a lot of units. 2, 4, 6, 8, 10, 12, 14, 16 units to the right. So you might have picked different positions. Describe how your points moved. My points moved up 3 units and 16 units. So look what I wrote. I said I'm gonna move each point up 3 units and write 16 units. For your shape, you should have different transformation. Okay, how many units did you move up or down? How many units did you move right or left? Depending on your image and your pre-image. Okay, that's part A. Part B, exchange instructions with a partner. Look at your partner's instruction. Follow your partner's instructions to draw a third shape. E, F, G, H in another color on the same grid. Okay, so from your partner, if your partner had a different instruction, you're going to graph your partner's point. If your partner said, oh, I moved all the points down 3 units, 1, 2, 3, and then write 1 unit. Okay, then you move D down 3 units and write 1 unit. Down 3, 1, down 3, 1, down 3, 1. And then graph your partner's transformation. And you're gonna call it, you're gonna label it E, F, G, H. Okay, so you should have 3 quadrilaterals total. E, F, H. Okay. So this is my imaginary partner's image. And then compare your drawings. Do they look the same? Well, yes, they look the same. They're just in a different position, right? If you move all the points down the same unit or up the same unit and left or right the same units, they're going to look like they're the same shape. They're just in a different position. Okay. So what makes a set of instructions for this activity a good set of instructions? How can you write a good instruction? You need to have both the horizontal distance and the vertical distance movement. You can't just say, oh, it went down 3, even if you had a horizontal movement, right? You need to have both instructions for both horizontal and vertical, okay? Even if you don't have a movement for horizontal or vertical, you have to specify there were no horizontal movement or there were no vertical movement, okay? Let's write that down. Good instructions include both the horizontal and vertical distances. To move the quadrilateral. Okay, so what are the properties of a translation is the question we're going to ask throughout this lesson. This transformation is called a translation. Okay, transformation, translation, they sound similar, but they're not the same thing. Transformation is including all the different transformations. In that transformation, we have a reflection, and then we have a translation, and we have more to come, okay? So translation is just moving your shape, up, down, left, or right. So look at this explanation of translation. A translation is a transformation in a plane that maps all points of a preimage of the same distance and in the same direction. The translation of this triangle ABC by x units along the x-axis and by y units along the y-axis can be written as T, capital T, sub x comma y. So you're going to write how many units you moved horizontally, comma, how many units you moved vertically. If it's positive, you're going to the right or up. If it's negative, you're going to the left or the bottom, okay? A translation has the following properties. If you draw a line from point A to A prime, and B to B prime, C to C prime, all these lines should be parallel. And all these lines should be congruent to each other. They have the same length. All the points move the same distance. Okay, all together. So triangle ABC and triangle A prime, B prime, C prime have the same orientation. They're looking at the same direction. That is called the same orientation. And also, translation is a rigid motion because length and angle measure are preserved. That is the definition of a rigid motion. Let's look at example 1 on page 112. Find the image of translation. What is the graph of translation? 7, -4 for triangle EFG. Okay, you see this notation. That is how you read it. Translation of 7 units right and 4 units down for all the points, E, F, and G. So you're gonna go count units 1, 2, 3, 4, 5, 6, 7 units right and 4 units down. 1, 2, 3, 4. That is your E prime. Okay, because that represents X and Y. Okay, so in a coordinate point 7, -4, it 7 represents the horizontal movement, and -4 represents your vertical movement, X and Y. This is not just a point, it's a movement for translation. Okay, so you go right 7 and go down 4 units. Okay, so you can think of it as left or right for your first unit, and up or down for your second unit. And for horizontal, going left is negative number, going right is a positive number. For vertical, going down is a negative number, going up is a positive number. Okay, so if you move all the points down and to the right, you're going to end up with this image: E prime, F prime, and G prime. 2, 0, 6, 1, and 5, -5. Let's look at this try question. What are the vertices of triangle E prime, F prime, G prime for each translation? Okay, so this is starting from the same triangle EFG over here. You have E, you can label your points first. Let's use a different color. E is -5, 4. F is -1, 5. And G is -2, -1. Okay. And if you look at part A, you're translating these points 6 units right, 7 units down. Okay. Come back when you're ready for answers. So looking at your points, you move 6 units right. 1, 2, 3, 4, 5, 6. Go down 7 units. 1, 2, 3, 4, 5, 6, 7. That's your new point. So if you want to do this algebraically, you're going to start with -5. So E prime should be -5 minus or plus 6, comma 4, which is your Y initial value, minus 7. And so that's equal to E prime is equal to 1, comma, -3. Okay, using the same steps, you're going to figure out F prime and G prime as well. Okay, so from your F, -1, 5, you're going to add 6 for your Y value and subtract 7 on your X, Add 6 on your x value and subtract 7 on your y value. So your f prime will be 5 comma negative 2 when you add 6 from negative 1 and subtract 7 from 5. And g prime should be 4 comma negative 8. Okay. Look at part B. Starting from the same points, E, F, G, you're going to move 11 units to the right and 2 units up. So starting from the same point, negative 5 comma 4, you're going to add 11. So negative 5 plus 11 is 11 minus 5, which is going to be 6. And so yes, from 4 you add 2 and that's another 6. So you got E prime as 6 comma 6. F prime, negative 1 plus 11, which is just 10. And 5 plus 2, which is 7. Okay. And the last one, G prime is negative 2 plus 11, 9. And negative 1 plus 2, 1. So these are your coordinate points, and this is how you write your final answer. Okay? You have to write E prime and then your coordinate point, comma, F prime, your coordinate point, G prime, your coordinate point. All right, let's look at example 2, writing a translation rule. Okay, you should be able to write a rule for this. So if you look at a graph, you're gonna write a rule like this, the problem in try questions, right? You already know that the symbol for translation is capital T, and then you need to include how many units they moved horizontally and vertically as the coordinate points. Okay, in the subsection. So look at these points. You're going to start from STUB. Your image is right here, S prime, T prime, U prime, B prime. You're going to use these vertex to see the changes in the movements. So from S to S prime, how many units down and how many units to the left are you going? So we're going to write X first, right? Your coordinate point starts with X. So we're going to count the horizontal movement first. We're going left 1 unit. Is that a positive or negative change? That's a negative change. So you're going to say negative 1 for your X value. And how many units are you going down? 1, 2, 3, 4. And if you're moving down, is that a positive change or a negative change? That's a negative change. So you're going to write negative 4 as your Y value. That is your translation. Okay, so writing the rule, you're going to say T for capital. And in the subsection, you're going to write these coordinate points, negative 1, comma, negative 4. And the symbol for quadrilateral, STUV. Okay. So the rule could be abbreviated like this. T sub parentheses negative 1, comma negative 4. All right. Let's look at try number 2. What translation rule maps point P to point P prime? Okay. You're not talking about the whole shape. There's no shape here. You just have a point and its image. So from point P, how many units do you have to move up or down, left or right? Okay, remember your horizontal movement comes first. Come back when you're ready. All right, so you're gonna write a rule, which means you're not just gonna say you go up how many units, you go right how many units. You have to know how to write the rule in terms of your symbol. Translation is capital T. And then it really looks like a parentheses, but actually you have a bracket, a point D parentheses over here, right? so that we don't confuse ourselves with a coordinate point and a motion, a translation movement. So from point P, you're going to count horizontal movement 1, 2, 3, 4, 5. So positive 5 for x value and positive 2 for your y value. So that is your translation of horizontal movement of 5 units to the right, vertical movement 2 units to your up. Okay, let's look at the next one, next page. Concept, composition of rigid motion. What is a composition of rigid motions? It's a transformation, it's the type of transformation with 2 or more rigid motions in which the second rigid motion is performed on the image of the first rigid motion. That sounds complicated, but it just means that you have 2 types of different transformation together at the same time, one after another. Okay, so here you can see that you have reflection and then you have a translation. So they're not going to be separated. It's not going to be one reflection and then there's an image and another translation and there's another image. They're going to have one final image. Okay, after reflection, you do a translation right away from that image, and the last one after reflection and translation would be your last image, your final image. Okay, we're going to notate it. We could notate it as 2 primes if we need to. Let's look at example 3. Compose translations. In learning a new dance, Kyle moves from position A to position B and then to position C. What single transformation describes Kyle's move from position A to C? Okay, we're just looking at A to C. Okay, if we represent 0, 0 as position A, how much movement did we move? We went 1, 2, 3 units to the right. And then we went 1 unit up, right? So we already know that he moved to B and then he moved to C. But in total, from the original position, you move 3 units to the right and 1 unit to your above, right? So you can say T bracket 3, 1 represents a single transformation that maps Kyle's move from position A to position C. Let's look at try number 3. What's the composition of the transformations written as one transformation? So if we have 2 translations, we can combine them by adding their numbers. Okay, so if you have 3 and 1, they're both positive. So if you add them, you're going to have 3 plus 1, because if you move 3 units to the right and then move 1 unit again later, that's total 4 units to the right. Does that make sense? So you're going to have 4 units total. Then -2, you go down 2 units, then you go down 1 unit again right after that. Then you have total of -3 movement. Okay, that's part A. Look at part B. You have -4 and -2. That means horizontally, you're going left 4 units and then 2 units to the left again. So total, how many left? 6 units total left. So that's -6 for your horizontal movement. Your vertical movement, 0, you didn't move at all for the first translation. But then you moved up 5 units. So in total, you moved 5 units up. So you just add the numbers for your translation if you have the same translation. Okay. Example 4. Relate translations and reflections. What if you have translation and reflection? How are they related? How is the composition of reflections across parallel lines related to a translation? Look at ABC, triangle and ABC, and then we got A prime, B prime, C prime. And then we have A prime prime, B prime prime, C prime prime. Okay, we have two transformations shown. First could be a reflection, and then we could have another reflection, or you could, if you have two reflections, you might see it as one translation. Do you see that? Do you see your pre-image and your final image? Yes, so that's what's happening really. Look at your step one. You reflect this triangle across the y-axis, and then you have prime, b prime, a prime, c prime. Okay, and then you reflect again across line M over here. Now you have a prime prime, b prime prime, c prime prime. But if you look at the original pre-image and the final image, you're really moving all your points 8 units to the right. Do you see that? So if you have two reflections, you might see that as a translation to sum up your transformation. So if you have more than one transformation, you can summarize your transformation using other form of transformation. Okay, so you can write this as, oh, reflection across y-axis. Okay, that's performed first, but for reflection, whatever you write first would be performed the last. Okay, times your original figure should equal to translation 8 units to the right of your same image, same pre-image. Okay, so that's what these symbols mean. Let's look at number 4. Suppose n is a line with equation y equals 1. Okay, and line n is y equals 1. Given DEF with vertices D 0, 0, E 0, 3, and F 3, 0, what translation image is equivalent to reflection of x-axis first and then reflection across line N? Okay, let's think about that. Look at, first you want to plot your points. Okay, I'm gonna plot points D, E, F. D is right here, 0, 0. Oh wait, that's not prime. And then E is 0, 3, 2, 3. And F is 3, 0. So that's your triangle. Okay, what translation image is equivalent to? Okay, first let's reflect. First, you reflect this triangle to the x-axis. So then all the points on the x-axis would remain the same by definition, by the property of reflection, right? So your D prime is still here, F prime is still here. Your E prime should be, however, on the opposite side of the x-axis, which is right here, 3 units away. So your triangle now looks like this. That is your first reflection. Your second reflection, it is reflection across line N, which is y is equal to 1. What is, where is your line y equals 1? Right here, right? So if you reflect all the points across y equals 1 line, your D 0, 0 is 1 unit away from y equals 1, right? Look at your y values. 0 is 1 unit away from 1. So you go up 1 unit because right now D is down from line N. Okay, so your new D prime prime should be 0, 2. Okay, what about F? it has a similar situation. You're not going to change your x value. You have 3, 2 instead. Okay, that's your f prime prime. Your e is 1, 2, 3, 4 units away. So from 1, you add 4. 1, 2, 3, 4. That's 5 for your vertical, your y value. And your x value does not change. So your e prime prime should be 0, 5. Okay. Connecting the dots, you see that triangle, right? So looking at your original triangle, your purple triangle to the brown triangle, what kind of transformation can you see? The translation, right? How many points, how many units are you moving the points up? 1, 2, 1, 2, 1, 2, 2 units up, right? Do we have horizontal movement? No. So how can you write translation of 3 units up in a notation? Geometric notation. T stands for translation. Bracket 0, 2 would represent no horizontal movement, but 2 units up movement. Okay? Look at theorem 3-1. A translation is a composition of reflections across 2 parallel lines. So translation could be just a translation, or it could be a composition of reflections across 2 parallel lines. And both reflection lines are perpendicular to the line containing the pre-image point, this corresponding image point. The distance between the pre-image and the image is twice the distance between the 2 reflection lines. Okay. Example 5, proving theorem 3-1. A translation T with T of C would equal to C prime. Okay, that's given. We have translation from C would equal to C prime. Okay, there exists, so we're gonna prove that there exists a parallel lines M and N such that translation equals reflection of N and reflection of M. Okay, we're just trying to prove there are 2 reflections that could make one translation true and the same between the image and the pre-image. So first, we're going to plan that the given information says that the translation T maps C to C prime prime. First, find the composition of reflections that map C to C prime prime. So we can say, oh, if we reflect over here, over line here, we can get C prime. Then we reflect here again, and we get another point, C prime prime. And then we're going to show that this composition of reflections is equivalent to the translation of T for any point, not just point C. Point C does represent any point, but not just a special point for any point. Okay. Let C be the midpoint. Let C prime be the midpoint of C, line C to C prime prime. And let the distance from C to C prime and C prime to C prime prime equals D. So this is D and that's D. Okay? Because if C prime is the midpoint, the distance should be the same. And if line M is perpendicular bisector of the line C to C prime, then N and N to be a perpendicular bisector of C prime to C prime prime. By properties of reflections, reflection on line M from C to C prime should be, and that should be reflections, right? So, so these 2 reflections could be combined to a composition of reflection, R reflection of line M and then reflection of line N. and that could be C prime prime. So the distance between N and M is D, and the distance between C and C prime prime should be 2D, right? All together total. So we're gonna pick another point B and show that this also is true. Okay, to do this, you're gonna show that B to B prime prime is equal to C to C prime prime, and that's also equal to 2D. Okay, and that the lines are parallel. So first we're gonna reflect across M, and then we're gonna let this distance B to M be X, and that's X. Okay, now we have a different distance. Now we're gonna reflect B prime across N. And we already know that this is D and that's D. So that would be D minus X because that's X. And that would also be D minus X because they're the same, right? Because that's a perpendicular bisector. Okay. So you can say that reflection across line M and reflection across line N would be equivalent to the translation of B. Okay, think about this question. Suppose the point B you chose in this proof was between lines M and N. So if you started with a point between these two lines, how would that affect the proof? How can you prove this? What are the possible cases you need to consider? Right, this could be a hard question, but how do you think the proof will change? Okay. We could still use the distances between the points. So you can still let the distance between point B and M be X. And then when you reflect B across M, the image B prime, the distance X from M, but on the other side of M. Okay. So if that's M, that's N. You can put B prime over here instead of, in the middle. And then when you reflect B prime across N, then that means you need to go further away. Whoops. So you should have a further point away from line N. The image B prime prime, the distance D plus X, right? Plus X, okay? So that should be D plus X because we need to reflect it across line N, okay? So instead of D minus X, we're getting D plus X in this proof. But it should be on the other side of N. The distance between B and B prime prime is the distance between B and N plus the distance between N and B prime prime, right? So we still have D minus, we still have D minus X plus D plus X, which is also equivalent to 2D, okay? So let's think about our lesson as a whole. We learned about translations and composition of rigid motions. Okay. A translation is a transformation that maps all points the same distance and in the same direction. Now, composition of two reflections across parallel lines is a translation. Okay. So from this lesson, you should be able to write rules for a translation and a composition of two reflections being one translation. That was lesson 3-2, translations. I'll see you in the next lesson. Bye.